Hi everyone, in this video tutorial we will learn how to simulate orthogonal cutting operation using Abaqus in 2D model. We will go through all necessary steps to run our job successfully and see our result of cutting operation in 2D model. We will analyze our results and get the maximum force for creating shapes in our piece, working piece. For this, first, let's start with creating of our stock or workpiece using workpiece name or stock 2D planner deformable shell and continue, and let's sketch our rectangular to represent the stock dimensions. 20 millimeter. All units in this sketch is in millimeter, and one we have 10 millimeter in the height of our sketch of or our specimen or workpiece, and with 20 millimeter in the length. Click done. Now we have 2D planar shape of our workpiece. Let's go to create our tool, cutting tool. 2D deformable wire. Continue, and let's create our tool, and let's add dimensions, and let's add this angle of cutting edge equal to 30 millimeter, 30 degrees. Okay, you can change this value. Let's change this dimension. Now we have let's return to the previous value, and now we have 30 degree of our cutting tool. You can change it depending to your tool used, and let's create radius value in this corner in the tip point or tip tool. Continue. We have radius in our tip tool. Now let's go to click done. Now we have cutting tool with analytic rigid. Let's create reference point. Now we have reference point. Let's go to property module and import material to our model. Let's rename it. Okay. Now let's edit and see the property in the material. We have elastic, density, Johnson-Cook damage parameters, and also damage evolution. Also we have plastic using Johnson-Cook hardening option and rate dependent. Click OK. OK. Now let's go create section. Shell homogeneous or shell homogeneous. Continue. Select thicknesses of our shell element, material, click OK, and let's assign this section to our We don't have section. Let's go to create another section. Solid. Continue. We need to create solid section, not shell section. And let's assign section to this. Now we have section 2 with aluminum. Section 2 with aluminum material. Now let's return to part module and partition this face to assembly with our cutting tool and refine mesh in the upper zone or the top part. Let's click done. Now we have partitioned this face. Let's go to assembly module and create two instances. Apply, cancel. Let's translate cutting tool to the right position. Let's go. Return. This position and let's translate in the move upper than this value. Now we have a right position of our cutting tool assembled with the workpiece. Let's go to step module and create dynamic explicit step. Step 1, dynamic explicit, continue, and time period. Let's take it as is 1 second. Click OK. Now let's go to file output, edit, and select failure, status to see some failure and plasticity models because we use Johnson Cook damage material model for plasticity and damage. Now let's go to interaction. First, before interaction, let's go to mesh and meshing our parts. Let's mesh our workpiece, the top side, apply. Okay, by size you can mesh, use method by size or by number, how many elements you need in this edge, or you can use by size of element. Apply. Okay, apply. Okay, now let's mesh these edges by number 25. Apply. Okay, mesh, click yes. We have mesh with finer size in the upper part and less size in the bottom because we are interested in this zone, not we don't use this mesh in this part. Let's go to element type, select, click on, and use plan stress or plan strain, reduced integration, explicit library, and select element deletion to delete element to delete damaged element. If element have a damage, delete. Click OK. Now let's go to cutting tool, mesh, apply. Okay. Yes. Now we have assembly. Let's add more refining mesh for our tool. And the type of mesh is analytic rigid, explicit also, and also beam. Let's use truss element. Okay. Let's convert this tool to rigid because we forgot to create as rigid. Let's go to part, cutting tool, edit, cutting tool, edit. Let's describe discrete rigid. We don't need as deformable, discrete rigid. Okay. And now let's go to mesh, apply. Okay. Mesh. Let's take a look at mesh element type. We have discrete rigid element. Let's use explicit. Okay. Now let's go to interaction. Let's create interaction between two parts, the cutting tool and workpiece. Interaction. Create property in the contact, mechanical tangential behavior with penalty, coefficient friction equal to 0.2 depending to your model and your assembly. Okay. Now let's create interaction with surface to surface contact. Click continue. Now let's select the first surface. Let's select the outer surface of our cutting tool. Replace. Select the wall surface, wall model. Now we have problem with this side. Let's flip before. Flip this. Now we have in the right direction. Let's select magenta color to represent the outer side of our edges and select node region. And now select the top part of our model. Click done and click OK. Now we have contact interaction property. This interaction, click OK. Now we have interaction between cutting tool and our workpiece. Let's create general contact with property all with self with this property and click OK. Now let's go to load module and create our boundary condition. Let's create symmetry, anti-symmetry on cursor. The bottom side, let's fix it. And the cutting tool should be have limited movement in the Y and Z direction. Displacement rotation. And click OK. Select reference point. Now let's limit the movement in the initial step. Now we have a wrong selection. In the initial step, continue. Select reference point. Click done. We have limited movement. And let's modify this to in the Y direction. Let's take displacement with equal to 0.2 depending to the distance of length of our workpiece. And now let's add amplitude before we have dynamic analysis. Click OK and select this amplitude. And let's reverse this sign of this value because we have in the reverse direction. Click OK. Let's take a look at the distance that should be the tool be moved on. We have the distance equal to 20 millimeter. Now let's go to mesh module, and now let's go to interaction and create rigid body. Click continue, and let's select analytic surface, select and select surface of tool of our tool, cutting tool, replace, select the wall model, select and select the outer surface with magenta color, but let's reverse this surface again. First flip surface, select, flip it. Now we have right directions of surface, select magenta and select reference point, select this reference point, click OK. Now we have error. The region corresponding to the analytic surface should be belong analytic rigid part instance. We can't use this because we have analytic rigid before. Now let's go to step, and now in this part, in this step, we need to use adaptive mesh domain using ALE method. Let's go to create or edit, step 1, use ALE adaptive mesh domain. We don't, let's create one, continue and click OK, click OK. We have value of frequency, remeshing sweep per increment, and initial remeshing sweep default. OK. Let's select first region of where we need to put our adaptive mesh control. We need to use this method in this part in the top of our workpiece. Select this zone, this, click done, click OK. Now let's go to job and create our job. Continue. OK. Data check. Now after completing job, we have completed successfully, but before going to analyze our result, let's go to see some modification in our model. We change the boundary condition, and also we delete the file, the adaptive mesh domain, we delete, and set no adaptive mesh domain for this step. Okay, because it makes problem. Also, we change the value in melting temperature and transition temperature. Okay, and let's go to the job and complete it, this simulation. Let's go to the result. Let's delete visible edge, free edges only. Okay, and plot our simulation. The cutting tool stop in this position because we start distance from this point to this point. It's take more, we should be at more than 2.0.02 should be more than this value, because this value start from this point. It's at this, like this point. We should be, for example, 3 or 4, means 40 millimeter or 30 millimeter, not 20 millimeter, because 20 millimeter starting from this point to this point, ending to this point. Not a problem. You can change it and rerun your model. Now let's go to visualization, and let's plot stresses, mice stresses, plastic deformation, status, our situation, our model. Let's see our general damage, general contacts. Also, let's go to mice stress. Now let's plot our force to see our force to create shapes and create cutting. Continue, select unique nodal, select also reaction force in x direction, plot, but we should to select node, this point, plot. As you can see, we have the force against the time, the force for creating shapes in our model. Let's go to operate on xy data and reverse the curve plot expression. Now we have force against time. The force necessitates for creating shapes and creating cutting in this material. Let's go to plot animation. Until now, I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you